Okay, this is the continuous class to the earlier one. Here a sample of nitrogen gas occupies a volume of 320 centimeter cube at STP. So calculate its value at 546.3 Kelvin and 0.5 bar pressure. So here at STP is given. So what are STP conditions? What is the pressure at STP? So 1.01 bar. Generally we are taking this 1 bar. What is value? So it is given, that is 320 centimeter cubes. So what is the T1? STP temperature, that is a fixed one, 273 Kelvin. So this is STP conditions. So the gas is transferred, nothing but changed to other conditions. What are the given conditions? So what are the given conditions? The P2 is equal to 0.5 bar. We need to find out its value, and T2 is given 546.3 Kelvin. Means here the simple one, the volume of nitrogen at STP is 320 centimeter cube. Then what is its value at these conditions? So volume depends on pressure and temperature. We know that in Boyle's law, Charles law, we know the volume changes. Nothing but volume depends on pressure and temperature. So its value 320 centimeter cube or at this pressure and temperature. Then what is its value at these two conditions? So what is the relation? P1 V1 by T1 is equal to P2 V2 by T2. We need to find out V2. So what is V2 is equal to, you can write P1 T2. P2. Here 273, here approximately we will cancel it. Okay. So it becomes 320 into 2. So 0.5 means nothing but 1 by 2. So finally we get okay, so 1280, sorry, 1280 centimeter cube. So this is the value of nitrogen at these conditions. Okay, right now. Okay, see the next one. Here totally a different condition that is given SATP. So generally we know STP conditions and NTP conditions, but here it is given SATP conditions. So what are SATP means? It is standard ambient temperature, standard ambient temperature and pressure. So what are SATP conditions? So SATP conditions, generally the pressure is 100 kilopascals and the temperature is 298 Kelvin, and the volume of 1 mole of any gas. So at STP volume of a gas is 22.4 liter. Okay, but here the value at SATP conditions, the volume of 1 mole of gas is 24.8 into 10 power minus 3 meter cube. So these are the SATP conditions. Now that 1 mole of gas is put into another conditions, means the dinitrogen gas is transferred into a vessel present at different conditions. That is starting the 1 mole of gas SATP దగ్గర ఉంది. ఆ SATP conditions నుంచి it is transferred to another vessel where the conditions are different. Okay, so what is the, so we are saying this P1, T1, V1. So we need to find out what is the final pressure. So what is T2? So it is given 596.3 Kelvin. So what is V2? 24.8 meter cube. Means here the problem is 1 mole of a pure dinitrogen gas SATP దగ్గర ఉంది. That is transferred to in a vessel present at 596.3 Kelvin. So at this temperature its value becomes 24.8 meter cube. Then what will be its pressure in the second vessel? Okay, remaining same just like earlier problem. Here we need to find P2. So we can write what is P2. T2 how much? Here see the exactly there is a cancellation takes place. This is 24.8, this 0.8, and here what is the 298? So here let's calculate this part. 590. So make it -1. Okay. So and it becomes how much? And for -1 into 596 we can write 59.63. Here, so P2 is equal, we will get 0.2. Okay, 0.2 then kilopascals. Here important thing is 100 kilopascal is equals nothing but we can write 1 bar. Okay, this means in the place of kilopascal we can write 100 kilopascal equal 1 bar. 0.2 kilopascals means into 10 power minus 2 bar. This is the pressure of dinitrogen gas at these conditions. Okay, write down. So here another very important model is that the drain cleaner Dranex means so it is just use it to clean the drainages which contain a small bits of aluminium which reacts with caustic soda. Caustic soda means what do you mean by caustic soda? Sodium hydroxide is known as caustic soda. To form hydrogen means aluminium react with caustic soda just giving hydrogen gas. So we need to find what value of hydrogen at a 20 degrees Celsius 1 bar pressure will be released when 0.15 gram of aluminum reacts. So ఇక్కడ సింపుల్ మనం ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే సో అల్యూమినియం 0.15 గ్రామ్ ఆఫ్ అల్యూమినియంతోని aluminum reacted with sodium hydroxide, how much hydrogen is released at these conditions. Okay, at first we must know the reaction between aluminum and sodium hydroxide. It takes place in aqueous medium. Okay, so main ikkada form ayedi sodium meta aluminate. So it is must to know the reaction. So aluminum react with sodium hydroxide aqueous medium, forming sodium meta-aluminate and hydrogen. So now just balance the equations. Okay, have the hydrogen 2 and 3 over there. Make it 2 becomes 4. Make it 3. It's 2 aluminiums. Sodiums. Okay, means here only discussion about aluminum and hydrogen. So NaOH also participated means there is no information about the NaOH and there is no need to calculate about the NaOH and sodium beta-aluminate. Just it is given the information about aluminium and we need to find the hydrogen. Just only compare that two only. So not only this problem, in any this type of stoichiometric problems, just we need to compare in balanced equation. After writing balanced equation, just compare the only those compounds in that one is of given information. So another is to calculate. Here again this equation 2 moles of aluminium releases 3 moles of hydrogen gas. Here 2 moles means here aluminum is given in terms of grams, so convert it to grams. At STP 1 mole equals which molecular weight? So that is equal to 54 grams. So write it in terms of moles only. Just further calculation, for simple calculation we are writing it as 3 moles only. So at last we convert it into values. Means so it applicable only at what conditions? At STP conditions only. Okay, so now it is the 554 grams gives how much? 3 moles. Then what about 0.15 grams? 0.15 grams of this aluminium produces how much oxygen? How many moles of hydrogen? That is 0.15 to 3 by 54. So here we get and finally the calculation, here we get 0.833. So that is equal to, we can write 8.33 into 10 power minus 3 moles. So here, so it is not the final answer. Say 8.33 into 10 power minus 3 moles of hydrogen gas is released when 0.1 gram of aluminum reacted. So it is the problem. 0.15 gram aluminum reacts. How much hydrogen is released? So we calculate it in terms of H2. So but here, so మనం దీన్ని ఫైండ్ అవుట్ చేయడానికి తీసుకున్న criteria this equation. In this equation we directly calculated 2 moles equal to 2 into 27. Means it is possible, this condition is only possible at STP. So means we got 8.33 into 10 power minus 3 at STP conditions. But in the given problem it is asked that what volume of hydrogen at this temperature and this pressure. Means ఇప్పుడు ఈ number of moles మనం ఈ temperature ఈ pressure లోకి కన్వర్ట్ చేయాలి. Okay. Normal STP conditions, given conditions P1 V1 by T1 equal P2 V2 by T2. So అట్లా ఫైండ్ అవుట్ చేయొచ్చు. సో ఆల్రెడీ మనం ఆ మోడల్ చేసాం కాబట్టి సో now we see the other model. Simple by knowing the PV is equal nRT. Just we need to calculate the what value. So value equals nRT by RT by P. Now what is the number of moles? R value how much? 0.0821 atmosphere liter per mole per Kelvin. What is the temperature? It is oscillating 20 degrees Celsius. This means 20 degrees, that is 293 Kelvin. What is the pressure is given? That is only 1 bar. So on this overall calculation, so approximately we will get on this overall calculation we will get 0.202 8 liter. So this formula applicable in only in liters. So convert it into milliliters. So this is the volume of hydrogen. Volume of hydrogen at this particular given condition. So simple ఈ problem లో మనం at first hydrogen value ni normal STP conditions లో find out చేస్తాం because we know the information at STP conditions. So STP condition లో ఉన్న moles ని we convert into other conditions. Okay. But here important is to know the reaction between aluminium and sodium hydroxide. So see the last one. So the total different from earlier problems. So here the temperature at the foot of a mountain is 30 degrees Celsius. Means at the down part. Okay, at the down part of the mountain temperature 30 degrees Celsius and its pressure is 760 mm. Whereas at the top of the mountain temperature 0 degree, the pressure is 710 mm. So we compare the densities at the foot and top. Just here no need to exactly calculate the values. Just we need to calculate nothing but compare their densities. Means we need to find the ratio of their densities. So we know the equation PV is equal to nRT. Here what is N? Number of moles. If you expand the number of moles, weight by molecular weight. So making this M this side, small m by V, mass by value. So what is mass by value? You know the density. So the Pm is equal to dRT. So what is the density? So what is the ideal gas equation in terms of density? So if you remember directly we can write in the problems. Means density is equal to Pm by RT. So now we take at the foot. Okay, at the foot, and afterwards we take at the top. Okay. So density at the foot. Density at the foot is equal to what? Pressure at the foot M. So next what is the R? So R is a constant. Here molar mass is also constant. Next T. What is the temperature will be changed at foot? Okay, say it is equation 1. Next, what is the density at the top? Again with this equation, pressure at the top, M, or no change, and the temperature at the top, equation 2. Now just compare these two densities. So just by making equation 1 by 2, the density of foot by the density at the top. Okay, on 1 by 2, just what we will get? All will get cancelled. There is no other cancellation. P foot by T foot and T top by P top. So P foot is how much? P foot, that is 760. What is T top? Temperature top 0 degrees Celsius means nothing but 273 Kelvin. What is the T foot? T foot is how much? T foot, that is 30. 30 means 303 Kelvin. Next, what is the pressure of a top? 70. So here, so on this final calculation, here approximately we will get and at last we will get 0.96 by 1. So this is the ratio. This is the comparison. Nothing but the answer is 0.96 is to 1. So we convert into another form also. Okay, just want to remember this density formula in terms of ideal gas equation. Okay.